Alright, so we talked about random access in the last video. So let's get started on changing our application to use a random access file and then to load these locations for the game on demand. Now, because we're going to have to change quite a bit of existing code, and also because it'd be nice to keep your existing project, the one we've worked on here to date, as a reference, what we're going to do is use a new project. Or rather, we're going to copy this project and create a backup version of it. So the easiest way to do that is to have the project open, which I've got, just to select the project up here and right click. And on a Mac I can reveal in Finder, and on Windows or Linux there should be an option, something like Open in Explorer or Open Folder or something like that. So click on that, and that takes you to the folder where that project is. So I'm going to just copy that. I'm going to copy and paste that. And you can see in my case on a Mac it's duplicated the folder, so you'll do something similar for your operating system. And I'm actually going to change the name of this. Instead of input output copy, I'm going to change that and I'm going to call it something completely different, Adventure Random. Because it really is the adventure game that we've been talking about and working on recently. And you can see that's been renamed. Now that I've done that, I'm going to close this project down, and then I'm going to navigate to that folder and open the new project. And again, we're doing this so that we can make changes to this code freely, and we don't have to worry about losing the original code we had. And Adventure Random is the name of the project, so I'm going to open that. Alright, so you can see now that I've got the Adventure Random project that I just copied and duplicated from our previous project open, and we're going to work on that moving forward now. And just before we start, let's just make sure that it still works. Right click and run. I'm running the main class's main method. And it looks to me that it's still going to work okay, but we'll just test this out a little bit. And I'll just put this up a little bit so we can see this a little bit better. North, southeast, and quit. That's working fine. Okay. Alright. Now we're going to use the locations.main method to use random access file to write out the locations. So our first step is going to be to write the number of locations to the file. So I'm going to open our locations class, and again we're making the change in the main method in locations.java, so up here. So our first step, as I mentioned, is to write the number of locations to the file. Now, since the file pointer is positioned at byte 0 when a file is first created or opened, we don't have to call the seek method that I talked about in the previous video. So consequently, it's pretty straightforward. All we really need to do is with this try, we're going to change this, instead of an object output stream, it's going to be random access file. And we'll call this an RAO is equal to new random access file. We're going to change the name of the file as well. So locations underscore rand.dat. The second parameter is RWD, which we'll talk about shortly. I'll get rid of this other code. And the code is raw.writeInt. And it's going to be locations.size. So again, it's the number of locations that we've got at the moment. We're writing that to our random access file, locations underscore rand.dat. Now I've called it RAO here because we're going to be loading locations on demand when we run the game. Now the locations data file will have to remain open while the application runs. So we're going to call the variable we use to read the file something different, so we don't confuse it with the one that we're using here, which is the one that we're writing the locations with. Alright, so the first argument to random access file is locations underscore rand.dat, and clearly that's the file name, the name of the file that we're writing it to. But this second option here, well, that indicates that we want to open the file for reading and writing, and also that we want writes to occur synchronously. Now you can open a file as read-only. We can also not specify that updates to the file have to occur synchronously, but if we do that and multiple threads can access the file, you'd actually be responsible for synchronizing the code yourself. So in this case, it doesn't matter since only one thread will access the file, but generally speaking, it's good practice to have the random access file class handle the synchronization when it does matter. So using RWD as we've used here on line 14 as the second argument is a good idea. Alright, so we've written out the number of locations so far to the file. What we'll do now is we're going to write the start offset of the locations section. And once again, since the file pointer is already positioned correctly, we can just go ahead and use write int. So we're going to type int index size is equal to locations.size times 3 times integer dot bytes. Then we're going to do int location start equals int index size plus RAO dot get file pointer plus integer dot bytes. Then we're going to do RAO dot write int, and it's going to be location start. Alright, so each index record will contain 3 integers: the location ID, the offset for the location, and the size or length of the location record. Now we're calculating the index size by multiplying the number of locations by the number of ints contained in each record, in this case 3 by the number of bytes contained in an integer. So you can see that we've done that here on line 16. So locations.size gives us the number of locations. We're multiplying it by 3. And again, the reason we're doing 3 is because our index is going to store the location ID, also the offset for the location, and then the size or length of the location record. And then we're multiplying that by the size of an integer, and we're getting that by using the integer class .bytes. So once we've done that, on the next line, we then calculate the current position of the file pointer to the index size to account for the value that we've already written to the file. And we also have to account for the integer we're about to write to the file, the location section offset we just calculated. So we also have to add the number of bytes to an integer. So we're doing that down here on the end of that line. So this will give us the offset for the location section. Now, as an alternative, we could also have added the index size to the size of 2 bytes, but I like to use the file pointer wherever possible, and I suggest that you should probably do that as well. And over here, we had to cast to an int, and that's because the file pointer is a long value. Now, we could have written a long, but we're going to read and write ints wherever possible. And I suggest you do that. And if you were working with an application with lots of data, such that the file offsets could be larger than an int could hold, then of course you'd have to stick to using longs to make sure you didn't exceed the maximum size of an int. Alright, so we've written out that location start now. Now the next section in the file is the index. But before we can write the index, we have to write the locations, and that's because each index record requires the offset for the location, and of course we don't know the offset until we've written the location. Now I guess we could write a location and then write the index record for it, and then write the next location and then write the index record for it, and so on and so forth, but that would actually involve a lot of jumping back and forth in the file. Now disk access is expensive, and it's even more expensive when it's not sequential. So instead what we're going to do is write all the locations, and then we'll write the index as a whole. Now to do that, what we have to do is build the index in memory as we write the locations. Now because we want to jump back to the file when we've finished writing the locations, we'll save the current position of the file pointer so that we can jump back to it when we want to write the index. Since we'll write the index after the 2 integers we've already written, we'd be writing it to offset 8, which is where the file pointer is currently positioned after writing the number of locations and the locations section offset. Alright, so what we'll do there, some code long, index start is equal to rao.getFilePointer. Alright, at this point we're ready to write the locations. Now we've already calculated the offset of the locations data section. Now we're going to assign that to a variable called startPointer, which will update after writing each location. And then we'll loop through the locations, write out each location, create an index for it, and add an index record to a map. Now to do all this, we really need an index record class, so we're going to add a new Java class called index record to our project. So let's go ahead and do that. New class, index record. So we're going to have two fields here, the private int start byte, which I mentioned, and private int length. We want a constructor, and the constructor should accept both parameters and save those to the fields. And let's also set up some getters and setters for this as well, for both of them. Alright, so there's our class, pretty simple. Now we said that an index record could contain the location ID, start, offset and length. And when we load the index records into memory, the location ID will act as a map key, and that's why we don't have to store it in the class, in case you're wondering. Right, so let's go back to our locations class and write out each location. Now I'm going to type in all the code first and then we'll discuss it. So we're going to start with and I'll just split this code up a little bit so it's easier to read. We'll start with an int start pointer, and that's equal to location start, and rao.seek start pointer. We're going to do for location, and locations dot values. Then we're going to do rao.writeInt, and it's going to be location dot get location ID, rao.writeUTF, and that's going to be the description, so location.getDescription. Then we want to create a string builder, so string builder is equal to new string builder. And then we're going to do for string direction, then location.getExits.keyset. If not direction is equal to quit or equals ignore case Q. So if it's not quit, we're going to do builder.append direction. Then we want to do builder.append a comma, builder.append location.getExits.get direction, and then builder.append another comma. Okay, and then just move this up a little bit. Then it's going to be rao.writeUTF, and it's going to be builder to string. And obviously I'm one level too deep. That actually should have been there, of course. We still want to stay in the for loop. And we also need to create our index record. So index record, remember we're writing the indexes later, but we need to build up this index in memory first. And so new index record, the first parameter is going to be start pointer. Then we also want to store an int, or cast that as an int, which will be the rao.getFilePointer take start pointer. Index.put, we need to create that in a minute. So location.getLocationID, and then the actual record, the index record itself. And then we need to update start pointer. So start pointer will then equal cast as an int rao.getFilePointer, whatever the current file pointer is. Right, so let's actually just add our index field. I'm going to go ahead and add it up here. So it's going to be private static. It's going to be map integer index record index equal to new. And it's going to be linked hash map, which obviously makes sense for our application, given there's a list of rooms that all link to each other in some way. So I'll initialize it like that. And that should mean that the code's ready to go. Now we've still got a bit of work to do on this. The video is getting a little bit long here. So let's pause the video and continue on this in the next video.